Assalamualaikum. Third class of sampling today. Let's start with this example. Fine, I'm starting with this example, which says the result of. I hope you can see the screen better.
Yes, I can see.
Okay, it says the result X of a stress test on a metal is known to be normally distributed with mean mu and standard deviation 1.3. It is required to have a 95% confidence interval for mu with a width less than 2. Find the smallest number of tests needed to achieve this. Okay, so let's do this. Width is less than, we know that for finding out the width is 2 multiplied by z standard deviation upon square root of n. Okay, and the width is less than 2, they're saying. Okay, 95% confidence level. So let's find out the value of z now. If it is 95% confidence interval, that means this is 95%. Okay, so 5% is left, so 2.5% here, 2.5% here. That means this whole area is 97.5% or 0.975. You have to use the normal distribution table, which is here, to find out 0.975, which is 1.96. I think so, but I'll still confirm it with my calculator just a minute. I'm just looking for the calculator. Okay, fine. Let's see. So 1.96, I have to check. 0.975. It's 1.96. Okay. So we're going on to this, and we know that the value z is I of z equal to 5 z 2 multiplied by 1.96. Standard deviation is 1.3, so you can just take 1.3 upon the value of n, which we are supposed to find out is less than 2. Okay, so I'm just cross multiplying here, so this becomes 2 under root n here, and I'm multiplying these three, 2 by 1.96, 2 into 1.96 into 3, 1.3. Okay, it's coming out to be 5.096. Okay, dividing it by 2. So I'm getting
2.5.
square root of n is greater than 2.548. Both sides 6.49.
Yeah. Okay.
N is greater than 6.49, that means n should be 1. Okay, na? Find the smallest number of tests needed to achieve this. Okay, so you have to have 7 tests to get a 95% interval. 95% confidence interval, and which should have a width of less than 2. Okay, so far so good. Any problem with this?
No.
Okay, so that means just focus your attention on the number. The sample size should be 7 to achieve a 95% confidence interval, and the width is less than 2. Okay, moving on to what the book is actually trying to explain here. Okay. Okay. Now suppose that in example, the same example they are referring to 4.16, which we've done. Now suppose that in example number 4.16, the 95% confidence interval for mu must have a width of less than 1. If you have the width of less than 1, then obviously if it is less than 1, then the value of n should have increased to 25.96. They've done it here. If you do the calculation again, for instance, and you want the width to be less than 1, okay, you want this to be 1. So
Yeah.
the value of n, when you square this side without dividing it by 2, 5.096 squared is actually 25.96. That means in that case, if you want the width to be less than 1, then the value of n should be 26 at least. You
Yeah.
understand the point? Okay, going back to the book here. Okay, so the smallest sample size needed for a width of less than 1 is 26 to have a 95% confidence interval. This is larger than the sample size of 7 needed for a width of less than 2. Okay, if you want the width to be less, okay, if you want the width to be less, then the sample size should be greater. This is the concept. Okay, in general, for a greater confidence level, the smaller the interval width, the larger the sample size required. Do you understand the point?
Yeah.
In general, for a given confidence interval, if you want the width to be smaller, then you have to take a greater sample size. Okay, na? If you have a smaller sample size, then the width of the bigger width would be there. Now, suppose that in example 4.16, the width of the interval must be less than 2, but the confidence is increased to 99%. If they increase the confidence level instead, the calculation needed to find the width is similar to 1 in solution 4.16, but replace 1.96 with the critical value of z for 99% confidence interval, which is 2.576 here. Okay. In that case, the width will, if you want the confidence level to be 99%, okay, or in other words, if you want to be 99% sure that the mean will have this value, then the width is going to be greater than 11.21 in that case. Okay, na?
Okay.
Sorry, the sample size should be greater.
Great.
So what is the result which they are giving you? In general, for a given interval width, the greater the confidence level, the larger the sample size required. Okay?
Okay.
Is this point clear?
Yes.
If you want uh, if you want more confidence on something, the sample size should be more. Okay, na?
Okay.
So we've got two results from here, which I'm highlighting with a red color. One is this. For the smaller the width, the larger the sample size required. Okay, and in other words, you can even highlight this. These are the 2 points which I'm going to send you this PDF. Just keep it in mind. So if in case if they ask you, you don't have to do the calculation again. You can use this concept to answer them. Just like we had a question yesterday, which we did yesterday.
Yeah.
Okay. Okay. Moving on to a few questions, okay, which I've selected, and then we can select more questions also. Okay, relating to the very first concept of sampling and everything. Okay, let's do this question. It says the editor of a magazine wishes to obtain the views of a random sample of readers about the future of the magazine. A sub-editor proposes that they include in one issue of the magazine a questionnaire for readers to complete and return. Give 2 reasons why the readers who return the questionnaire would not form a random sample. Can you think of any reasons? What is a good sample? What is a
I would say because they've already completed it and returned it, right? So it's not random.
The thing is that every member of the population should have an equal chance of getting selected. Here, only those people are selected which are reading that particular magazine, that particular issue of that magazine. So yes, so this does not make a random sample.
Yes.
Or these are the people who are actually filling up the question and returning to you, that these are more committed readers actually. So this does not make a random sample. So yeah, you've got all sort of readers who are just reading, some of them are not even reading the magazine and they're buying it. Some are the ones who are just reading a particular page only. They're just buying the magazine for a particular page. They're not reading the whole thing. So you are actually asking the more committed readers, so they do not make a random sample.
So it's a more biased opinion.
Okay, then they're saying the editor decides to use a table of random numbers to select a random sample of 50 readers from the 7,302 regular readers. Okay, these regular readers are numbered from 1 to 7,302. The first few random numbers which the editor obtains from the table are as follows. Use these random numbers to select the first 3 members in the sample. You have numbered people from 1 to 7,302. That means you're supposed to pick 4-digit numbers. Okay. So The first 4-digit number is 4975.
Mhm.
Then you can take 7802.
Yeah.
Then you can take 3952. Then you can take 0386 or 3. After that, you can take 882.
Yeah.
Is there any repetition which you're supposed to look at? Is there a number which is going beyond this 7,003? Yes, this is going beyond. So you just have to leave this. So you have to select the first 3 random numbers. So you can select these 3. ठीक है ना? Get rid of this also. समझ में आ रहा है बेटा?
Yes.
Okay. I had intentionally selected 2 questions, ठीक है, of sampling, so that we're done with this concept actually. Here you can go through the questions. If you come across any, then we can discuss about it. Okay, let's this one also. It says Dominic wishes to choose a sample of 5 students from the 150 students in his year. He numbers the students from 1 to 150. Then he uses his calculator to generate 5 random numbers between 0 and 1. Okay. He multiplies each number by, which numbers? Between 0 and 1 only. He multiplies each number by 150, whatever the number. For instance, 0. Just a minute. Between 0, generate 5 random numbers between 0 and 1, meaning decimal numbers.
I think so. Yeah.
Okay,
because-
fine. For instance, yes, 0.4. He multiplies each random number by 150 and then rounds up to the next whole number to give a student number. Okay, fine. So if I multiply 0.4 by 150, I'm getting a 60. And then he rounds it up to the next whole number. This is the next whole number only. Okay, so this is one number. ठीक है.
Okay.
Okay. The random numbers can be any decimal number. सही है तो the first number which he has generated between 0 and 1 is 0.392. Find the student number that is proposed by this random number. Okay, you are supposed to multiply this number by 150 as a first step. So we're getting for the first part, you are supposed to multiply by 150 and we are getting 58.8. So round it off to the next whole number, which is 59. So the student who has this number will be chosen. Okay, the next one. Dominic's second number is 104. Find a possible random number that would produce this second number. Okay, this is the result. Okay.
So this
And the
divided by
random
1.
number we don't know.
Yeah, divided by 1.
Okay, great, excellent. 104 divided by 150, and the answer is coming out to be 0.693.
3.
You can even choose a smaller number than this because then you have to round it off to the next whole number. You can take it to be 0.691 also. ठीक है ना? But you
Okay.
can give this number as well.
Okay.
Then explain briefly why 5 random numbers may not be enough to produce a sample of 5 student numbers. Because several numbers can round up to the same number. Same
The
whole
5 student numbers are
then.
not accurate enough.
हो सकता
I
है.
mean, yeah.
So you may have to take 6 or 7 numbers because if they are rounding off to the next whole number and the next whole number is the same, then obviously you will have repetition, and in case of repetition, you have to take another number or maybe 2 numbers if there are 2 repetitions. Are you getting it?
Yeah.
Okay. This is a question. Acha, I would like to do one question from continuous value distribution. I would like to do one from Poisson and one from binomial at least before we move on to the normal questions. So one is this question which I've chosen, which is the length x centimeter of a piece of wooden planking is a random variable with probability density function given by this. This is the probability density function where b is a positive constant. Find the mean and variance of x in terms of b. Okay, so you have to find out the mean and variance. Fine. For mean, what do we do? You remember? What do we do in order to find out the mean?
So we have to do the integration.
You have to do the integral, but 1 upon b is a constant, so that is going to come out, and
No, so that comes
the
out. Yeah.
constant which we are using is okay, fine. The
And then
constant is
our
x and the boundaries are b and 0.
Yeah.
Now we're going to integrate it.
Mhm.
1 upon b, x square upon 2, and the boundaries are b and 0. Let's plug in the boundaries. 1 upon b, b square upon 2 minus 0 square upon 2. So it's going to be 1 upon b into b square upon 2, which is b upon 2 is the mean. In terms of b, you have to give me. Okay? For variance, are you getting it, Beta?
Yeah, yeah.
Variance of x equals to, or I'm doing it down below. Yes, I'll do it here. Mhm. For variance of x, the formula is you take out 1 upon b as common, square this,
Square dx.
apply these, which are pen is not writing, I have to charge it. I forgot to charge it. I'm so sorry. एक मिनट देना बेटा. Huh?
Okay.
Achha, then you have to subtract what? The mean square from this. This is going to give you summation x square b fx, and then from that you have to subtract the mean also, square of the mean. Okay, to get the variance. Okay, let me complete this question. Dot dx. Okay, the boundaries will be b and 0 minus e of x, the whole square is going to give us the answer for the variance. So 1 upon b, when we're going to integrate this, is will become x cube upon 3, the boundaries will be b and 0, minus b upon 2, the whole square. Where did I get this b upon 2? The mean square. So,
Yeah.
so it's going to be 1 upon b cube upon 3, 0 I'm not putting, minus b square upon 4. Simplify this, b square upon 3 minus b square upon 4. And this will become, if I take out the LCM, 3 and 4 is 12. So 4b square minus 3b square, which is b square upon 12 is the variance. Is this clear, beta? कुछ पूछना है इसमें से?
No, but I'm just gonna go through it again.
Sure. Look here. This was the normal function. I had squared it, and then I've applied the boundaries of b and 0. I have integrated this x cube upon 3. I applied the boundaries. Okay, so when I apply the boundary of b here, it'll become b cube upon 3. And 0 ki boundary I'm not putting because there's no use. 0 upon 3 would be 0 only. So simplifying this is giving me b and b will cancel out, b square upon 3. Achha, what is this part? I'm subtracting the mean square from this. Mean ka answer, if you notice, is b upon 2. So minus b upon 2 square, I have to subtract from this. And I've simplified it, taking out the LCM.
Okay. Yes.
Okay. Then it says the length of a random sample of 100 pieces were measured, but it was found that summation x is 950. ठीक है?
Mhm.
Show that the value of b estimated from this information is 19. Can you tell me how do we go about doing this part? We already have the mean with us.
Yeah. Okay. Do we just sub it in? So 950 is equal. No. Wait. Do we have to?
What is the other
put
formula to
that
find out the
proof,
mean?
right? No,
What
we
is
have
the
to.
other method to find out the mean? You have to prove that the value of b is 19.
19.
We found out the mean in terms of b now. But if
Yeah.
in case, what is the other method to find out the mean is summation x upon n? They've given us summation x is 950 and n is 100. So if we can find out the mean and equate to the mean from here, which is b upon 2, we can get the value of b. Okay? Are you
Okay.
getting what I'm trying to
Yeah.
say?
Yes.
Okay, let's find out the mean. B upon 2, I can write in the second part, for the second part, b upon 2, which is actually the mean, is equal to summation x upon n. So b upon 2 is summation x is 950 divided by 100. Cross multiply 100b equals to 950 times 2 would be 1900, and b equals to 1900 divided by 100. So 19 is the value of b. Got it?
Yeah.
Okay, then they're saying use this information, this value of b, find the probability that a length of a randomly chosen piece is greater than 11. Okay, so you want the probability, that probability x is greater than 11. Just the same concept which we've done continuous probability distribution. May if you want the probability of something which is probability greater than 11, okay, and the value of b we know is 19, so 0 till 19 is actually the domain here, or you can say is the range of this. So you want it to be greater than 19, so you'll apply the boundary of 19 and 11. Upper bound will be 19 and the lower bound will be 11. Sahi hai? And we are going to integrate this, which is 1 upon b. Okay, I'm writing 1 upon 19 is the function. Okay, and we have to, the upper bound is 19 and the lower bound is 11. You understand this much?
Yes.
Okay, so we are going to simply find out the integral and then apply the boundaries and we will get the probability. So it will be 1 upon 19 x. Okay, so boundaries are 19 and 11. So 1 upon 19, 19 minus 11, which is actually 8. Fine. So 8 upon 19 is the probability. This is the answer. Are you getting this much?
Yes.
Generally, how do we find out probabilities with the continuous, then the probability density function? We integrate it, we integrate the function, and then we apply the boundaries. Since they said greater than 11, that means greater than 11, but obviously the upper bound is 19, so 11 till 19 you have to find out apply the boundaries and get the probability. Okay, then in the last part of the question they are saying this is what is related sampling. Okay, find the probability that the mean length of a random sample of 336 pieces, mean length, okay, is less than 9 centimeter. Since they have not mentioned the probability distribution here, whether it's normal, binomial, Poisson, whatever. Okay, but it can't be a binomial, it can't be a Poisson also. The reason being binomial and Poisson are discrete distributions. We will apply the properties of normal distribution here because the sample size here is, we don't know what continuous distribution, is it normal or is it something else, but since the sample size is greater we can apply the property because of the central limit theorem. Central limit theorem says even if the distribution is not normal but the sample size is more, you can approximate it to normal distribution. So we will approximate it to a normal distribution. Okay, so we have to find out the better idea is write down a very short statement here. Since the sample size is greater than 50, I told you one book says 30, the other book says 50, so you can use 50 or 30, whatever. Since the sample size is greater than 30, so we can apply. So according to, or you can say, so according to central limit theorem. Central limit theorem. Mean of x has a normal distribution with, we already know the mean, and the mean was 19. Okay, and the variance was in terms of b here. If you notice, b square upon 12, so 19 square upon 12 is actually 361 upon 12, which is 30.08. This is the variance. Okay, this is the thing which we'll be using, 30.08, and 30.08 divided by the sample size, which is actually 336. We've written the distribution of this. Now we just have to find out the probability. What are they saying is that find the probability that the mean length is less than 9. So you have to find out probability mean length is less than 9 equals to probability z is less than 9 minus 19 upon 30.08 upon 336 in the square root sign, and get the probability. Getting it?
Wait, I'm a bit. Could you explain it again, please?
Sure, why not? Which part? How did I get the variance? You understand?
No, can you explain the variance part again, please?
Sure, why not? Dekho, what I was trying to say is that the distribution they are not saying is normal, but since the sample size is more than 30 or 50, you can say that you can approximate to it to be a normal distribution. Okay, na? So we already knew that the mean is actually b upon 2. Okay, so the mean is 19 upon 2, which is 9.5. ठीक है ना? So the mean is 9.5. And the variance, if you plug in the value of b in this, you're getting 30.08. So you can say that the distribution is normal and the mean is 9.5 and the variance is 30.08 divided by the sample size. Are you getting it?
Okay, okay. Yeah, got it, got it.
And you have to find out the probability that the mean is less than 9. So I'm standardizing it. 9 minus the this value of the mean, which is 9.5, divided by the square root of this here. So I'm
Yes, okay.
calculating this and I will get the probability. So
Okay.
9 minus 9.5 is a 0.5 on the top, divided by 30.08 divided by 336 in the square root. Okay, so it's 0.299. 0.5 divided by this. Okay, it's coming out to be probability z is less than minus 1.67. Less than minus 1.67 is this part. Okay, so you have to, you can write 1 minus 5 of 0.1.67 will give you the probability. Are you getting this much?
Yes.
Because
Okay.
you are assuming it to be this part, and 1 minus 5 of this will give you the probability. So 1.67 you have to read from the normal distribution table. 1.67
0.9525.
okay, 0.9525. It is actually 1 minus 0.9525.
Yeah, so that is 0.0475.
0.0475. This is the answer.
Yes. Okay.
Okay, Mary wants to choose another question. We are starting. It says Mary wants to choose one student at random from Anthea, Bill, and Charlie. She throws two fair coins. If both coins show tails, he will choose Anthea. She will choose Anthea. If both coins show head, she will choose Bill. And if the coins show one head and one tail, one of each, meaning one head and one tail, she will choose Charlie. Explain why this is not a fair method of choosing the student. Can you tell me why? Can you think of any method?
Is
Can you think of?
Yeah, I was just thinking maybe one is that it won't be a fair chance for everyone. Like, let's say there's like they always get two heads or two tails. Not everyone gets a equal probability of being
Okay, you
chosen.
have to clearly mention. Okay, I do understand
Yeah.
that. Dekho, when you, the probability of getting two heads is 1 upon 2 into 1 upon 2, which is 1 upon 4. Probability
Yeah.
of getting two heads is tails is also 1 upon half, 2 into 1 upon 2, which is 1 upon 4. But probability of getting a head or a tail can be first head, the first tail, or it can be first tail, the second one is head. So half into half here plus
Yeah.
half
So
into
160.
half here. So this is half actually. So the chance, the probabilities are not the same. Obviously, that means this person is going to get, has a more chance of getting the um, of getting chosen. ठीक है ना? Of being chosen. So you will say that since the probability, if you want, you can even mention the numbers of uh, two heads being chosen. Two heads in a toss of a coin equals to 1 upon 4. Probability of two tails is also 1 upon 4. But the probability of getting one head and one tail is 1 upon 2. So they don't have a fair chance of getting selected. ठीक है ना
Yeah.
बेटा? Just write it in short. Although मैंने बहुत बड़ा लिख दिया, although मैं इसको बहुत short भी कर सकती थी. Since the probability of two heads and two tails is the same, but the probability of one head and one tail is greater. Therefore, short करके लिख दो बस. Getting chosen is different. Okay, the next one. Describe how Mary could use the 2 points to give a fair method for choosing the student. Yes, can you tell me?
Maybe if she could, uh, maybe if she could flip the coins one at a time, and the person that gets heads first and then tails can be chosen, and the person that gets tails first.
Dekho,
and-
she has to specifically mention for the first person. If she has said for Anthea, you will get a chance if I get both heads. The other person is Bill. You will get a chance when if I get both tails. The third person, which is Charlie, she will say you will get a chance if I get the head first, and the second
First
time
and
I
then
get the
tails.
tail.
Yeah. So then
Specifically, she has to mention.
equal amount chance for everyone.
So that they have an equal amount for chance for everyone. The same probability for all of it. Okay, the next question. Say it.
Okay. Wait, so how would we write
I'm not
that?
right.
Don't write it. You can
Uh,
tell me how we would write it.
No, you can. She has to. Mary has to specifically mention that Charlie will be chosen if she gets one head followed by one tail. One head. She gets a head followed by
A
a
tail.
tail, or a tail followed by a head. सही है ना?
Then do we also have
Specifically,
to
she has
say that only one can be chosen? Only one.
भाई आप हाँ और लिख दिया ना मैंने देखो if she gets a head followed by a tail or a tail followed by, or if you don't want to write this, if you're getting confused with this, you can just omit this. She can specifically mention that he will get, say na,
Okay.
one of the two will be okay.
Sure.
Okay, then it says, okay, this is a question from binomial which I've chosen. Okay, random sample of size 120 are taken from the distributions. This find fully the distribution of the sample. Okay, since n is greater than 30, the sample mean is normally distributed with, first I'm going to find out the mean, the expected value of x, which is x equals to np, which is 15 times 0.4, which is 6. Okay? Then I'm going to calculate variance of x here, npq, which is 15 times 0.4 times 0.6. 1 minute. Variance of x is npq, which is 15 times 0.4 into 0.6. Okay. 3.6. Okay, so it has a mean of 6 and the variance is 3.6 divided by the sample size. Is this clear?
Yes.
You just have to give this. Since n is greater than, therefore, because of central limit theorem, use the word theorem. Find the probability that the mean of a random sample of size 120 is greater than 6. You have to find out the probability that mean is greater than 6.1. So it's going to be probability z is greater than 6.1 minus mean upon 3.6 upon 120 in the square root, and get the probability. Are you getting this part?
Yes.
I hope I'm not going fast with it.
Oh no, you're doing okay.
Okay, so the answer here is 0.577. Okay, you want it to be 0. Greater than the positive number 0.577. You want this part, so it's going to be 1 minus 5 of 0.577. 1 minus 5 of 0.577 we can read from the table. 0.577. Okay, 0.57 is this number, and then underneath 7 here on in the same line is 24. So 0.7157. Okay, I'm writing it here. 0.7157 plus 0.0024. Is this clear?
Yes.
Okay, so this is coming out to be 1 minus 0.7181. 0.2819 is the probability. Okay, so we're done with this question also. Okay. I had to choose one from Poisson distribution, which I found, but then I think I didn't copy it. I want to do one from Poisson also. Just a minute. I'll just find it out in a while. Did you see the file which I've sent you yesterday?
Yeah, I went through it.
Okay. So you have to do questions from there, as many as you can. And then in the next class, I will choose some difficult questions, and the ones which you will ask me to do, I will do them. Okay? So I'm taking one from these. I can take any one of these two. I can take the first one or the second one, whatever you tell me. Come on. Which one shall I take?
I think the second one.
Whenever the sample size is greater and the distribution is Poisson, you can apply you can approximate it to be a normal distribution, and you can use the central limit theorem and go for the solve the question the normal way. We have to do this question right now. After this, we'll be having our class on Tuesday. So you've got good Friday. Today's Friday, Saturday, Sunday, Monday. Tuesday, we have a class in the morning, 10:30. So you have 4 days around to practice the past papers, and then you can tell me the questions which you don't understand. Okay, so let's do this one. X and Y are independent random variables with distributions. The distribution of X is this one, and this obviously is the mean. Poisson mein there's just one parameter, which is one, the mean. And this is the distribution of Y. The mean of Y is 2.3. Find ये तो अभी से Poisson वाला part चल रहा है. Poisson x plus y equals to 4. You have to find out the probability of x plus y equals to 4. So I can introduce a variable t. Let t equals to x plus y. Okay, so mean of t is going to be mean of x plus mean of y, which is mean of x is 1.6 and mean of y is 2.3. Add them up, we are getting 3.9. 3.9. So the mean of t is 3.9. You want probability x plus y equals to 4. That means probability t equals to 4. Okay, so it's going to be, you have to find out the probability t equals to 4. So it's going to be e to the power, the mean is 3.9. No? So 3.9. 3.9 to the power of 4 upon 4 factorial. You remember this Poisson distribution formula?
Yeah.
Okay. I don't need to explain this.
No.
You want probability t equals to 4. So x is 4 in this case. ठीक है ना? बल्कि इसको यूं नहीं लिखना चाहिए था, मुझे इसको यूं करके लिखना चाहिए. Probability t equals to 4. Yeah. So let's solve this and get to the answer. E to the power minus 3.9 multiplied by 3.9 to the power of 4 upon 4 factorial, which is 24. So this probability is coming out to be 0.19. 3 significant figures that you have to give the answer. This is the answer for the first part. Then they're saying a random sample of 75 values of x is taken. State the approximate distribution of the sample mean x, including the values of the parameter. Okay, you will write since n is greater than 30, according to the central limit theorem. Sample mean is normally distributed. Acha dekho, if you notice, they're talking about the distribution of x only. So the mean is 1.6. So mean is 1.6, and the variance of a Poisson distribution is the same as the mean. Do you know this? Mean and variance of the Poisson distribution is the same. So 1.6 divided by the sample size, which is actually in this case 75. You understand?
Yeah.
What am I doing? Mean and variance is the same. That's why I wrote the same numbers here, but obviously the variance has to be divided by the sample size. So this is the first part done. Okay, so this is for 2 marks. The third part. Hence, find the probability that the sample mean is more than 1.7. So you have to find out probability the sample mean is more than 1.7. So obviously you have to convert it to Z now. Probability Z is greater than 1.7 minus 1.6 upon 1.6 upon 75, the square root. Solve this and minus 1.6.1 divided. Okay, I'm getting
0.685. I got 0.685.
I'm getting a 0.684. Can we check again?
Yeah, it's, I mean, I got 0.684, but I just rounded it up to 685.
Okay, greater than 0.684 meaning you want this. So 1 minus 5 of 0.684. So 0.684 from here. Okay, 0.7517 divided plus 0.7517 plus 0.0013. It's giving me 0.0753. 0.753. 1 minus the answer, which is 0.247. This is the answer for this part. Then they're saying explain whether the central limit theorem was needed to answer part 2. Yes, it was required as the distribution is not normal and the sample size is more. It was required as the distribution is not normal and the sample size is large. Whenever the distribution is not normal but the sample size is large, you have to apply the central limit theorem. What does the central limit theorem says? It says even if the distribution is not normal but the sample size is large, you can approximate the distribution, either it's Poisson or binomial or whatever, to normal distribution, and you can apply the properties of the normal distribution to find out the probabilities. Okay, beta? Are you clear with this much?
Yes.
Okay, let's do this question now. The time in minutes taken by people to complete a walk are normally distributed with mean mu. The time for a random sample of 80 people was summarized as follows. Calculate a 97% confidence interval for mu. Okay, not a problem at all. First of all, we need the mean and the variance, which is compulsory. So we have to find out them. Although they didn't ask for it, they never said find out. They could have made this first part, and they could have said find the unbiased mean of unbiased estimate of the mean and the variance, but they didn't keep it as a separate part because they want to check whether we find it out or not. We have to find it out on our own because that is a compulsory thing. Because for getting the interval, if you remember, the formula was this. This was the formula. We need the unbiased estimate of the mean and the variance both. So we have to find out. That is why they kept this part to be for 6 marks. So we have to have a sense of finding it out. Okay, unbiased estimate of the mean would be summation t upon n. Summation t is 7220 divided by the value of n, which is 80, which is the sample size. Okay, so I'm dividing 7220 by 80 and I'm getting 90.25. Okay, the unbiased sample variance would be 80 upon 79. The formula stays summation t square upon n minus the mean of t the whole square. Okay, so 80 upon 79 on outside, t square is 656,000,060. 656,060 divided by the value of 80 minus the mean, which is 90.25 square. Okay, so I'm just solving this. $56.39 is the sample variance. Okay, fine. So we need to create the for a 95%, 97% confidence interval. Phi of z equals to, you want 97% confidence interval, that means this should be 7, 3 is left, so 1.5 here, 1.5 here. This whole area should be 0.985. Okay, so I'm using the table. 0.985 is not here, so we can find it out from here. Are you getting what I'm trying to do? I'm finding out 0.985 from here.
Yeah, okay.
Here, 0.985, so it's 2.17. Are you getting it?
Yes.
I can show you. 0.985 is 2.17. Phi of z equals to 0.985. Z equals to, what was it? 2.17?
Yes.
Was it 2.17?
Yeah, it was 2.1.
Okay, fine. So x plus minus z. This is the formula. Okay, so mean is 90.25 plus minus 2.17 into, I can just put this whole thing as 56.39 upon square root of 80. Okay, I'm calculating this part first. 1.82. Okay, once I'm adding it to 90.25, I'm getting 92.07. I'm rounding it off to up to 3 significant figures. And once I'm going to subtract it, 90.25 minus 1.822. I'm getting an 88.4. This is the confidence interval which we've created. Okay, the next part. Up till now it's clear. Any problem?
No.
Explain why it was necessary to use the central limit theorem in part 1. Because the sample size is large and the distribution is not normal. Simple. Okay, na?
Yeah.
Because I'm writing it in short. Sample size is large and the distribution is not normal. Okay, let's do this one. The weight in grams of orange grown in a certain area normally distributed with mean, mu, and standard deviation. This, a random sample of 50 of these oranges were taken and a 97% confidence interval of mu based on the sample is this. Calculate the unbiased estimate of the mu, and you have to find out the unknowns. Now you have the lower limit, you have the upper limit with you. You know the formula for the lower limit is mean minus the value of z. This is a 97% confidence interval. Let's find out the value of c first. Phi of z equals to, if it is 97, that means 1.5 here, 98.5, which is 0.985. Phi of z 0.985, which we found out to be 2.17 in the previous
No.
question, I think so.
Yes, 2.1.
Yes, 2.17. Okay, so z is 2.17. So x plus minus 2.17, we don't know the value of the standard deviation and even the बल्कि इसको आप यूं कर लो, बल्कि नहीं, let's keep it to be standard deviation upon n, and ठीक है ना, if you have to keep it positive and you can take the bigger number here, 232.1, and once you have to keep it negative
Okay.
and keep the rest smaller number here, which is 222.1. ठीक है, sample size is 50, so you can keep square root of 50 in the square root. Okay, the better idea in order to solve this is that you make solve this part 2.17 divided by square root of 50 and shift it onto the other side. I'm just solving 2.17 divided by square root of 50 first. 2.17 divided by square root of 50 is actually 0.306. So I'm just making it simpler now. X plus 0.3069 sigma equals to 232.1. Okay, so I want to make mean the subject, so it will be 232.1 minus 0.3069 sigma.
Okay.
इसमें भी आप mean को subject बना दो, इसमें भी, because that is the best way of solving it according to me. 2.17 divided by 0.306, एक मिनट, square root of 50 is that 0.306. Okay, it's going to be minus 0.3069 sigma equals to 222.1. So mean becomes 222.1 plus 0.3069 sigma. This is also mean. Now you equate both of them because mean is the subject in both, so you can equate them. Use the substitution method. That means this equals to this. Are you getting my point? We're using the substitution method here.
Yeah. Okay. Yeah.
232.1 minus 0.3069 sigma equals to 222.1 plus 0.3069 sigma. I'm shifting both the ones with sigma onto this side to make it
Yeah.
positive. So 2 times 0.30, 0.306. 3069
Yeah.
sigma equals to 232.1 minus 222.1. 10. Sigma equals to 2 divided by 0.3069.
So it's 16.29.
Great. 16.29. So the variance would be 16.9 ka square, which is 265.427. So three significant figures would be this only. Mean we can find out by substituting it in any one equation. So I'm using equals to 222.1 plus 0.3069 sigma, which is 16.9. Solve this. So it's coming out to be 227.1 aa raha hai beta.
227.28. That's what I'm getting.
I'm getting a 0.1. Chalo, theek hai, whatever. If I can just round it off to 27.
Yeah.
Fine. So we've got the mu and sigma both. ठीक है ना, unbiased estimate of this will be that. ठीक है ना, ये दोनों हो चुके हैं. So we are going on to the next part. Estimate the sense. अच्छा, this part is important. The next part. It says estimate the sample size that would be required in order for a 97% confidence interval for mu to have width. Fine. Width ka formula. If you remember the formula of width, I'm just revising it with you. Width is 2 times z into sigma upon this. ठीक है ना? And this is 1.8 they are saying. So 2 times, they are saying 97% confidence interval. So obviously the same number, 0.2, 2.71. Sigma we know is 16.9. Square root of n equals to 1.8. We just have to solve this part. So I'm just multiplying these two, 16.9 by 2.71. I'm getting 45.79 and multiplying it by 2, I'm getting This whole thing I'm getting 91.598 upon under root n equals to 1.8. So 1.8 under root n equals to 9.91.598. Okay, divided by 1.8 is 50 point under root n equals to 50.887. Squaring it will become just a minute.
589.
Okay, 2589.565.
486.
Okay. 2590. सही है बेटा?
Yeah.
Our answer is not correct.
It's different.
Just a minute. Let's check our answers for the mean, which is 227. Very good, it's correct. And the other one was 265. That is also correct. The second part is also correct. Estimate the sample size that would be required in order for a 97% confidence interval from you to have width 8. Oh, I wrote 1.8 instead of 8. I'm so sorry. You understand?
Okay.
It
Yeah,
was
yeah,
not
got it.
1.8, it was 8.
Okay.
बस थोड़ा सा fixing करनी है वो हो जाएगी ठीक है ना so just have to make it into 8 and then you have to solve it सही है ना so quickly if we can solve we can just write down the answer from there because that was a very clear cut mistake n is coming out to be 78 ठीक है बेटा so we're done
Yeah.
with this much. We'll continue inshallah on Tuesday with the questions which you will ask me to do from the past papers or I will
Okay.
choose some difficult questions on my own also.
Okay,
ठीक है
sure.
चलो
Yeah.
बेटा have a good day. Thank you so much. I'm just mailing you this file.